Good morning, Year 11, and welcome to another science lesson. Today we're going to move on to the electricity topic properly now, and we're going to look at circuit diagrams, circuit symbols, how to draw them, how to interpret them. Before we do this, we need to make sure we've done the do now, so if you haven't, please pause and then come back in a few minutes. Okay, so question 1, what is meant by a renewables resource? That is one that is constantly being replenished as it's used. So if we want to use an example here, when we use solar energy, sunlight, that's constantly being produced by the sun, so it's not going to run out, it's always being replenished, whereas coal, once we burn it, it's not being made at any great rate, so it's not being replenished, so that's non-renewable. Environmental impacts of coal combustion, that releases CO2 into the atmosphere. Two energy resources that give out CO2, well, we've spoken about one, that was coal. You could also have mentioned oil, and you could also have mentioned natural gas. These three are all fossil fuels. Okay, equation for kinetic energy. Can't be a do now without that, so EK is 0.5 times mass times velocity squared. What is the equation for internal energy change when an object is heated? So delta E, so it's an energy change, is mass times specific heat capacity times by the change in temperature. So this symbol here is called a theta. We use that to represent temperature. Okay, so moving on. So the crux of today's lesson is basically going to be remembering all of these symbols. And we'll talk about these loads. So if you can't remember them all at once, don't worry, we're going to revisit them time and time again. We'll use these to draw circuits shortly, and there are a few guidelines or rules that you can use to make sure your circuit diagrams get the marks that you need them to. So if you want a circuit that works, you're going to have a power supply and energy supply, like a cell or a battery, and that supplies energy to the charge carriers, the things that flow around the circuits inside the wires. You'll also need wires to carry that charge, a pathway to carry the charge. You're probably going to need a component that transfers energy from the circuit. So if your cell provides energy to the circuit, if the wires carry energy around the circuit, then a lamp will convert electrical energy into light energy, so that's taking the light energy out of the circuit. I've just included a few descriptions down here, so I'm not going to read through these, but I'd recommend that you pause the video, read through these, and make sure you're familiar with what each of these does. So that's just useful for you. Your first task today is to name the circuit symbols. I'll do the first one for you. This is a battery. I know it's a battery, not a cell, because a cell just consists of one pair of lines, so one big line, one small line, whereas this is a collection of cells. So I might even just add that a battery is a collection of cells. If you're stuck, you can go back to this page, you can check that, oh, well, look, that is a variable resistor, and so on and so on and so on. Okay, so this is what I want us to be able to do. The reason we use circuit symbols is that sometimes these, if we were to try and draw the components and the wires in a circuit, that would be quite tricky. So it's not very easy to draw, and it's not very easy to interpret. So if we have a look at here, I've got two lamps. Here I have, well, it's 1.5 volts. So one cell usually equals 1.5 volts. So if my potential difference here is 1.5 volts, then I can draw a cell. If it was something like 4.5, that means there's 3 cells, so that would be a battery. I've got the wires here, and then finally I've got this clicky thing here, which is a switch. So I need to convert this diagram into a circuit diagram. So I'll usually start off with my cell and my battery. That is 2 parallel lines, one is longer than the other, and this is where it's going to be tricky for me, but you'll be able to do better, I'm sure. I come out of the left, this side of the battery. The first thing I encounter is a switch, and I'll draw it open. Doesn't matter if it's open or closed. So if it's looks like this, it's open. If it were in a straight line here, touching this contact, that would be closed. I'll come out of the switch, and then I'll draw my 2 lamps or bulbs. So lamp is the preferred thing to call them, bulbs is also correct. 1 bulb, 2 bulb, and then I go out of this side of the bulb, up here, and I join with the other side of my circuit. When you're doing this in the exam, you're going to have a pencil, you're going to have a ruler, so I'd recommend using a pencil and a ruler. These lines should be straight and they shouldn't be crossing over each other at any point. They should just look like this but straighter. You can also label your cell up with the positive terminal and the negative terminal. The bigger line is positive, this one is smaller. So we say the current flows from positive to negative. So we might have current flowing round here, completing the circuit back in there. Okay, so you have a go. You will be, it's much easier if you have a go at this using a pencil and paper or pen and paper at home. You'll find it quite difficult to draw on the screen, but give it your best shot. Just do whatever you can. If you wanted to submit or email me photographs of your diagram, you can do, but that's by no means necessary. Right, so we're going to look at different ways to model circuits now. This is a diagram, a stylized representation of what's happening in a circuit. So we have our battery here, our cell collection of cells. This provides energy and this makes the charge move around the circuit. So these charge carriers are electrons, but they're, so we say it's charge moving around in this direction. What's actually happening is electrons move in the opposite direction, and we'll look at why that is a little bit later, but we'll call them charge carriers or charge to just for today. So this battery provides energy to the charge and makes them move. So these charge carriers start flowing around the circuit. As soon as the charge starts to move, this bulb lights up. So the charge delivered to the bulb where it's transferred from electrical energy to heat and light. So the energy that's supplied by the battery gets taken out by the bulb here. That goes around here. So the charge carriers have lost their energy. They go all the way back around here and they go back to the battery and they collect more energy. So let's say charge carriers move in a loop, or a circuit if you will. They collect energy at the battery and they lose energy at the lamp. If I make these charges speed up, I'm increasing the current, and that means that more energy is going to get delivered to the bulb in a certain time and that bulb will appear brighter. If I have more batteries, so if my battery is bigger, it provides more energy, it gives even more energy to each of these charge carriers. I've increased what's called the potential difference. The potential difference is the measure in the difference of energies in between these 2 points. So over here, they don't have any energy, whereas once they come out of the battery on this side, they've got lots of energy. So all these charge carriers over here have got loads of energy. They pass through this bulb, give up their energy, and they have no energy again. And the idea of potential difference is just the measure of the energy given to each unit of charge. So if it's a 1.5 volt battery, we could say that each unit of charge has 1.5 joules of energy. If we replace it with a more powerful battery that might have 3 volts, then each of these charge carriers would now have 3 joules of energy. It's twice as much. If you compare the difference in energies between these two, because this is 0, this is 3, the difference in the potential energies is 3 volts. So what I would like you to do is look at this model of a circuit. So we have vans that travel around here. They go to the bakery and they collect bread at the bakery. They move around there, they take the bread to the supermarket, and they unload their bread at the supermarket. So think about what's going to be represented by the vans themselves, what's represented by the road, what does the bakery represent, what does the supermarket represent, and what happens if we increase the speed of the vans, what happens if we load more bread onto the vans. Okay, I'm going to give you 3 or 4 minutes, pause the video, try and answer these questions, and then come back and check your responses. So what does the bakery represent from the circuit? Well, this is the cell or the battery, whatever's providing that power. How are we doing for time? The vans represent the charge carriers. So we could say they're the electrons that move around the circuit. What in model represents energy carried around the circuit? So the energy is represented by the bread. What in the model represents the bulb? So what transfers the bread, the energy out of the circuit? Well, that's the supermarket. And then what do empty vans going back to collect bread represent? They're charge carriers without any energy. So speeding up the vans increases the current, and loading more bread to each van is like increasing potential difference. Okay, thank you very much, Year 11. Enjoy your weekend.